Welcome, ladies and gentlemen, to Binary Life, and today we are going to be solving another 7Q kata on the codewars. Just for a reminder, Binary Life is a channel that will help you solve multiple algorithm and data structures, so that problems, so that you can view the walkthrough and understand the thinking process and be good at programming in your own turn. So let's get to understand this problem right now. In mathematics, an nth root of a number x, where n is usually assumed to be a positive integer, is a number r which, when raised to the power n, yields x. Well, you can pause the video and read quietly so that you can grasp the question properly. But this exercise is about basically what it's asking is if you're given a number, determine that the second root, that's the square root, the fourth root, and the eighth root. Determine that they are all integers, that they are numbers without fractions, something like that. That they are whole numbers, if you wish. For example, let's go to the terminal, the node terminal, so that I can run some Javascript. Now the second root, we all know the square root of 16 is 4. So if I say 16, before going to do the testing, I want you to remind you of one thing. The second root of a number is like multiplying that number. It's like raising that number to the power second root. Let me write it down. It's like raising the number to the power 0.5. So I'm in JavaScript right now. If I raise a 16 to the power 0.5, I get a 4, and we know that the square root of 16 is 4. That's it. And in the same light, the fourth root of a number is like raising that number to the power 0.25. You just need to do 1 divided by 4, you get 0.25. The same here, 1 divided by 2, we get 0.5. So in the same logic, the 8th root of a number will be the number raised to the power 0.125. Like here, if we see this example here, the 8th root of 256 is 2. That means if we raise 256 to the power 0.125, we're going to get a 2. So if we write 256 raised to the power 0.125, we get a 2. So that's the logic we're going to use to solve this. So right now, we have to verify that the second root, the fourth root, and the 8th root are whole numbers. Like if we redo this example, the 8th root for 257, we see that this is not the whole number, because as we can see, the fraction part, it said the fraction part, it should be 0, but here it is not 0. And we also need to check if a number is a whole number in this algorithm. And how do we do that? To check if a number is a whole number, you just need to do the modulo of that number by 1. For example, if I declare number n to be equal to 5.0, now if I do 5 division of the remainder of the division of 5 to 1, what do we get? We get a 0, so it's a whole number. What if we change n to 5.004? Now this is not a whole number anymore. So if we do the remainder, we see we get something different from 0. So if we take the modulus of a number by 1 and it returns 0, it means it's a whole number. Let's do one more try. So if I do 3.000, the modulus of that number to 1, we get a 0 because that's a whole number. If I add just 1 here, I don't get a 0 anymore. So putting all of that into perspective, what do I need to do? I need to check if the power of the second root is a whole number, and equally the fourth root is a whole number, and thirdly the eighth root is a whole number. If I can get all of those three to be whole numbers, and then we can return true for this function. That's basically the exercise. So I can do all of that in one line. I can return if n to the power 0.5 modulo 1 is equal to 0, and also is an AND condition. All of the three needs to be true. 0.25 is equal to 0, and 0.125 is equal to 0. If all of them are true, this function is going to return true. If any one is false, the whole of this statement is going to be false. So let's run the test. We can have a parse. And we are good to go. I think this should be one of the simplest approach to this algorithm. I just want to submit so that we can see if there was something more simple in the other submissions. Alright, this is another function, JavaScript function to get the power of something. That would have been good too, like 2 to the power 3 is 8. 2 to the power 3 is 8. So I could say math.pow 2 to the power 3. That's how that function is used. We get an 8, which means if I wanted to get the square root of a number, like we know the square root of 16 is 4, so it's the same like raising 16 to the power 0.5. We get that. So we could have used the power also, and that will work. And this guy practically did a loop. This is very, very wise, very, very clever. I can just think of like the best solution, because he just created a loop for 2, 3, and 4, and at every looping, 1 is divided by r, and r is either 2, 4, or 3. This is very, very clever. So we could use the now every means every looping should return true. Let's see. This is crazy. Now this is like a shortcut, because he has just checked the 8th root. Now if a number has an 8th root, let's see, if a number has an 8th root, then it automatically has a 4th root and a 2nd root. Basically that's it. It automatically has. So he just checked the last one. If it doesn't have an 8th root, then it doesn't have a, if it doesn't have an 8th root, then it's automatically false. That's like a shortcut, because if a number has an 8th root, it automatically has the 4th and the 2nd. So he just based his checking on the 8th root. This is very, very clever, but you need to know the math behind it. Now this is like the first we just looked at, and this is a way to break it down into multiple ifs and else if you don't know the shortcuts. All right, I'm gonna stop there. So you can see the multiple approaches. This is a very wise one, and this is like a senior cleaner solution. So see you on another video for another kata, and thanks for watching, and don't forget to subscribe for more algorithm and data structure questions we're going to be dealing with.